All right, good evening, everybody. Welcome you to the first ever meeting in 2016. And this evening, we have Phil Willink. Heard his name. He was with the Field Museum, and currently he's at the Shed Aquarium. And he's the senior researcher at the Shed Aquarium. I'm just kidding. Two announcements. One is that the Winter Festival program is here, if you haven't seen it. And one of his research associates will be there talking about mud puppies. And he's in charge of the research. But we didn't invite him here to talk about that. We invited him to talk about fishes at Wolf Lake. And Wolf Lake is an amazing lake, and this is one reason that it has more than a century's history of data on fish. And I don't know if that can be said for many lakes around. So that's just one more reason why Wolf Lake is special to us. But his name came up even before, I think before he moved to the Shed Aquarium. I was having a discussion one time and was talking about how, humans intervened to take care of a couple lakes, Berry Lake and Hyde Lake. But they also intervened to sustain lakes. And they did that with Wolf Lake. And it was your discussion in your article on the succession of lakes. And so somebody questioned me, a professor at UIC. And I said, well, Bill Willink said it was true. So
did it help? I don't know. It may hurt you sometimes. I don't know. Was it?
Because you initially quoted somebody from 1913.
Oh, yeah, sure.
Studies on, but then you went on, and in your next paragraph, that was you. It wasn't your explanation of it. The second announcement is that Calumet College annual Humanities Festival will be held April 4th through the 8th. And then this year, our theme will be creation. Besides holding our usual forum that week, would any of our group's participants like to contribute to the festival? Your ideas are most welcome. Now, I didn't say that, but Valerie did.
Yes, we're still very much in planning stages for the festival, but the theme is tied to Pope's encyclical about the global environmental crisis, and it just happens that we do have our regular forum scheduled for that week, which is very apropos. But if anyone, certainly everyone is welcome to come to any and every one of the events. They're all open to the public. And if anyone has any ideas they'd like to share about an event they'd like to see, that would be marvelous.
Anyway, I'd like to introduce Phil Willink, and we're going to learn more about Wolf Lake.
Do you normally have the lights on or off?
I'm going to turn them off because it's going to help us. I like that, by the way. I like that photo. That's Wolf Lake terminals in the background. Mm-hmm. And we've been in court for 3 years because they are discharging petroleum wastewater. They've been causing us problems. Anyway, but I like that view.
That's what I used to. First of all, I'm a pretty informal speaker. So if you have questions while I'm up here, feel free to holler, wave your hand, whatever. If it's a long question, maybe wait till the end just to be, considerate of everybody else's time. But if it's a short question, if I'm not clear about something, please just go ahead and ask. I am going to talk about Wolf Lake, and this is Wolf Lake, but I'm going to talk about Calumet in general. Okay, so it's going to be a little bit bigger picture than that right there. And I also sort of notice that on your flyer for the series, you also have past, present, and future, which I didn't actually realize. I put this up here totally independently of your flyer for whatever reason.
Well, great minds.
That's right, I know. And this actually sort of synthesizes kind of how I do my research to some extent and how I approach my problems. If I were to try to find a common theme in my research, it's how fish communities or assemblages change over time. And these changes can be from season to season. They may be year to year, decade to decade, sometimes century to century, and sometimes even longer. You know, scientists sometimes think really, really long time scales. But then I try to figure out, why do these fish communities change? What's the driving force? Is it a natural? And there are a lot of natural changes, or is it human-induced? And depending on that, should we do anything about it? How does this influence how we do management decisions, conservation decisions for the future of these particular aquatic ecosystems? And tonight we're going to focus in on the Calumet ecosystem. And one reason I kind of like this picture right here, and this is one of these, strange dichotomies and juxtapositions you see in the Calumet region, is so in the background you have all these, these oil storage facilities. Over here you have all these plants, so healthy aquatic ecosystems right here. There's actually, if I could, not today because it's covered with ice, but in August or whatever, we could go as a group with a net and we could find a couple species of endangered fish living right here. Go around the corner and there's these mud puppies, these endangered aquatic salamanders, and we could find them over there. Maybe in a couple weeks, if there's enough ice, we could do that right there. The water's fairly clear. Over here we have something of a wetland. We'll pretend it's a wetland, but then over here we have a steel retaining wall. Okay, so you got all this weird stuff, all in the same place. Here, this is where you can dispose of fishing lines. So people fish, sit here and fish for, and the lake stocked with fish. We have duck hunting over here. So you have all of these uses all in this one area. And so, some would say the Calumet region has had, a lot of use, some would say abuse over the decades, and yet there's still an amazing biodiversity here, which makes this a really special place. But this talk tonight isn't really going to be about people, it's going to be about fishes. And so I'll introduce you to a few of the characters here. Yeah, that'll be all right. This right here is an eel. I'll talk a little bit more about eels in a little bit. This, you can't see it too well, but it's called a black striped top minnow. It's only about this long. If you walk along any of the local rivers or lakes, chances are you've seen those fish. You may not have known at the time, but they swim right at the surface. They're fairly conspicuous. Pollution doesn't bother them. Habitat degradation doesn't bother them. They're pretty common in the Chicago area, one of our more common fish for that reason. This is pumpkin seed sunfish. It's in the same family as the largemouth bass. These are native fish. People love to catch these. Kids will catch these right here. This is the northern pike. This is another popular fish that you can catch in some of the wetlands in the area. And then over here, this is a freshwater drum, yellow perch, and these are sculpin. These tend to be more Lake Michigan fish. So in the Calumet region, I'm also sort of going to include a little bit the shoreline of Lake Michigan. That's how I see it. It's a very different ecosystem than Lake Calumet, Wolf Lake, the Calumet River, and stuff like that. But it's still more or less in the area, and they're interconnected. There was a paper in the late 1800s, which was on the fish in the area, and they documented how when storms would come up, a lot of water from Lake Michigan would pile up into the Calumet and push up into the Calumet River, and the Lake Michigan fish would go up with them into the river. And after the storm, the river would push all of that back out, and these riverine fish would then start moving back to where they were prior to the storm. So it's not a solid line between Lake Michigan and every place else. It is a very fuzzy line, and fishes and other aquatic organisms are certainly moving back and forth, and that's what some of these are. This is a freshwater drum, some call it a sheep's head. They get relatively large. I won't go too much into fish anatomy, but fish have two sets of jaws. They have the one up here, which you can think of, but they also have another one here in the base of the throat. And in this fish, it actually has malariform crushing teeth. So this can eat mussels and clams, things like zebra mussels. It'll put them down there, crunch them all up, and then eat them. And that's sort of how it makes its living. Some other fish, catfish. We have several species of catfish in the Calumet area. Some can get pretty large like this. Others only get about this big as maximum size. The reason they're called catfish is they have these barbels or whiskers, so that's kind of obvious. What not so many people possibly know is that these barbels in their skin are actually covered with thousands of taste buds. Okay, so these fish are nocturnal. They have eyes, they can see, but at night, one of their primary senses is they literally taste the environment. And if there's something out there, another fish or a dead fish or something like that that they want to scavenge on, they will actually taste the water column and track down this plume of chemicals until they find it and then eat it. So they don't even have to really be able to see. Fish just don't sit around and hang out or whatever. They do lots of different types of things. This is a bluegill, once again another common fish in the area. It's actually right here. You can't see it very well in this picture. But this is actually a nest. So the male has come along and used his tail and cleaned away all the sand and sediment over this to clear out this area. And he will then guard this nest. The female will come in, they'll court for a while, she'll lay her eggs, he'll do his thing. He will then protect the eggs and the young until the young leave from any predator. So if a crayfish comes along, another fish comes along, or if a person comes along, he will then charge them and try to drive them away to protect the young. And once you get an eye for what these look like, you can walk along many of our local rivers and lakes and you can see these. And bass do the same thing, and then a number of other relatives within the family do the same basic behavior. So this is an American eel. This is an interesting fish because we don't find many in the Calumet region. There are records from Wolf Lake and others like that, but they're not from here. All right. All American eels are actually born in the Sargasso Sea in the middle of the Atlantic Ocean. All right. Most of them then swim to the Atlantic coast of the eastern United States. Some, however, swim all the way through here, Gulf of Mexico, all the way up to the Mississippi, all the way up to here, a distance of around 3,000 miles. All right. And it can take, it takes a long, long time for them to do this, a year or so, maybe more. They then live up here for several years, possibly longer, and then swim all the way back to the Sargasso Sea to spawn. All right. So that's one of the more unusual members. We do not see very many of these anymore because of all the locks and dams in the Mississippi River, the Illinois River, and a number of other barriers that are in their way. But we do still find them from time to time. Here's some other fish. This is a muskie or a muskellunge, depending on what you want to call it. These are in the area. They're native, but most of the ones that we find now are stocked primarily for fishing purposes, and that's one of the management aspects of management of a lot of these fisheries is putting the fish in there so that people can go out and catch them. It's a recreational fishery. This is a smallmouth bass, once again, native fish, more common in Lake Michigan than the inland lakes, but you'll find them in Wolf Lake and other places like this. Once again, they do reproduce naturally, but they're also stocked once again to enhance their numbers so that more people can catch them. So there's a lot of game fish in the area. Sturgeon. So this fish is actually from Lake Erie. There's always a lot of talk about sturgeon. Are there sturgeon in the Calumet area? What's going on with the sturgeon? There's a lot of stories. Are these stories true? That sort of thing. I will tell you right now that if you go back 100 years into the 1800s, there was actually a sturgeon fishery, not a large one, but a sturgeon fishery in the Calumet area. All right, so they were here, and they were here in fair numbers. I'm not going to say super, super abundant, but they were fairly common. It would not have been unusual to go out and find one. If you had large nets, which was the way they caught fish at that time, you would have been catching them, and they would bring them into Chicago and sell them in the market for various purposes.
About how big is what we're looking at?
This one right here is around 5.5, 6 feet. Yeah, so they get large. So this is the largest fish in the Great Lakes. I've seen them up to around 6 feet and worked on them on that size. They can get up to 7 these days. Historically, we think they reach lengths of 9 feet. So they're the largest fish in the Great Lakes. They're also the longest lived. We estimate that they could live up to 150 years. All right. They don't do that anymore because these have been severely overfished, but historically we think they're 100, 150 years old. Very large. They don't become sexually mature until 15 to 25 years, something like that. So it takes them a very long time before they can have babies. And that's what we're doing a lot of restoration projects to bring these populations back. But because it takes them so long before they can reproduce, these are not seasonal projects. These are decade-long projects carried on.
Can I ask a question about the sturgeon?
Yes, sure.
I don't remember what the source was, but Lake Calumet supposedly has one of the largest sturgeon, sort of a bottom feeder or whatever, and has been living off most of the grain from the grain elevators that used to be there. And as I recall, they were reliable sources, but it kind of surprised me that there would be something huge there.
Oh, they will go into shallow water. They'll go into 4 or 5 feet of water. And we know that, we track them, and they do that. Typically at night they'll come in, possibly if it's that shallow, then go out deeper, that sort of thing. So that's a possibility. Now these days there's a lot of stories, and one fisherman did supposedly catch one at one time. There's a bit of a debate as to whether it was a transplant or did it swim here or something like that. That we don't really know. There is, but I will tell you that there are native sturgeon in the area because occasionally dead ones roll up on the beach on Lake Michigan. So we know that they're making a comeback in Wisconsin and Michigan, and we know that they're swimming around the edge of the lake. So we know they're here. Now, we would not be able to go out and actually catch one. You know, it'd be like a 1 in a million shot of actually finding them. But we do know that they're out there in low numbers and increasing in numbers over time.
Are you familiar with Tom Simon?
Yes. Yep.
He wrote a 4-page or 5-page article or paper, which he said that George Lake that's where they used to spawn. And then when they built Calumet Avenue, probably in the 1930s, it closed off. And his argument was that he, I don't know if he actually saw them in Wolf Lake, but he said that they were probably left behind once that that they would still be in Wolf Lake. But there was one caught there. The one that was caught, though, was from Wisconsin and had been tagged. And so,
yes.
So somebody was trying to maybe make some news. But there's I've never heard of any being caught. So.
No, not recently. No, just these dead ones that we find along Lake Michigan from time to time. There are actual records, old records from Lake Calumet. There is no actual record of a sturgeon, except this one that was caught with the tag that people are questioning. There's actually no records for sturgeon from Wolf Lake or others, but they're from the Calumet River. They were probably in Wolf Lake because the whole area was a wetland and the fish were going around all over the place. There's a bit of a debate as to how much spawning they really did in the area. Typically what they spawn over is rubble or cobble, big rocks like this or something in fast current, which is not the Calumet region. Possibly up on the moraines they may have, I don't know. But what they do is their mouth is right here, it's below, and so this is an ideal place for feeding. So I have no doubt they're here in large numbers feeding, historically. Yeah. But we destroyed a lot of their numbers. They are making comebacks, and I think we're going to see more and more of them over time, but it's going to take a while. So anyways, so sturgeon, these are always a popular topic. Technically here, but good luck finding one. Another fish. This one's along the Lake Michigan shoreline. This is a long-nosed dace. It is actually the official fish of the city of Chicago. All right. Not many cities on this planet have official fish, but Chicago's one of them, believe it or not. It's a small fish. It's only about this big. We find it in Lake Michigan. And in Illinois, we only find it really in Lake Michigan and then some parts of the upper Mississippi. So it's relatively uncommon here. Does anyone know how this became the official fish?
No, but I was going to ask.
There you go. All right. Nobody remembers. So this happened maybe 10, 15 years ago. I forget the exact dates. They decided, in true Chicago fashion, to have an election. All right, to decide what the official fish should be. And they put forward several candidates, and a colleague of mine wrote a little paragraph description of several fish. And I think one was yellow perch, and another bluegill. I can't remember them all. Long-nosed dace was the one. And he wrote a description where saying that these things body surfed in the waves as you were kids swimming out there and that sort of thing. Does anyone have any idea as to how they won the election?
I don't really speculate.
Sort of, okay. Basically what happened is one particular constituency really fell in love with this particular description, namely school kids, and voted overwhelmingly in favor of the fish and basically carried the election. So this became the official fish. And they're fairly common out there in Lake Michigan, you're sure. Okay, we had Chicago in the background. Here's Chicago again. I said we were going to talk about the past a little bit, so let's pretend we're in a time machine. We'll take Chicago in a time machine, and let's go back around 15,000 years, and Chicago would look like this. Okay, more of something like this. All right, there was a giant glacier here. All right, roughly about a half mile to a mile of snow and ice sitting on top of the region. And this is always a convenient starting point because these glaciers came through and scraped everything away. And so there were no fish or anything else here. So that's always a good starting point for a lot of these particular talks. This was not the only glacial period. There were actually several of them coming over the region, covering large parts of the globe. These melted, roughly around 14,000 years ago in this region, depending exactly where you are. A lot of people say that glaciers created the Great Lakes. That's not exactly true. I mean, it's partially true. Most of these Great Lakes were actually pre-existing river valleys or rift valleys. What the glaciers did is they came through and scoured out some of the sediment. That sediment was then deposited oftentimes over here in these hills or moraines. Many of these moraines are now forming the edge of the Calumet region, the edge of the watershed. And then as they melted, the water filled these depressions. So they supplied the water for this. They didn't really, and dug it out a little bit, but they didn't dig the really, really deep holes. The shapes of these lakes obviously changed as the glaciers were melting. Also, lake levels went up and down. So these are lake levels in Lake Michigan from 14,000 years ago to roughly the present. Around 12,000 years ago or so, waters were actually 50 feet higher than they were today. So this room would be underwater if we were holding this talk 12,000 years ago. And then at another point, several thousand years ago, lake levels were down a couple hundred feet, we think, at least 100, something around in that area. And in that respect, the Calumet region was actually bigger because it extended out into Lake Michigan. And this is a picture actually from Lake Huron, but we have similar ones, just not as clear, at least I don't, of tree stumps and tree logs on the bottom of the lake. So offshore of the Calumet area, there's actually sunken forests. So we have evidence that at one time the forest went that far out into Lake Michigan at one time. Then the water levels came back up and basically cut the deal out. And this is just sort of another, just to show that over time the outlets of the Great Lakes differed. Sometimes there were connections here to the northwest. For much of its history, Lake Michigan actually flowed out through into the Mississippi. And other times it came out, these flowed out this direction and this direction. Most of the fish that we now have in the Calumet region are actually from this part of the world, down here in the Mississippi drainage, and then recolonized coming up here following the glaciers. Some came from the northwest through the Great Lakes, some came from the northeast through the Great Lakes, but that's where these fish came from. Most came from down here, moving north, following the melting glaciers over time. Water levels are still going up and down. These are water levels in Lake Michigan Huron over the past century or so. But I would like to point out that from the peak water level to the lowest water level is a distance of about 6 feet. So we're not talking about 50 feet, 100 feet anymore. We're talking about 6 feet. You may remember back in the 1980s, water levels were really high. Recently, we've been talking a lot about really low water levels. That's a whole nother discussion. I have a whole, another hour-long presentation on why water levels go up and down. So I won't go into it today, but I just want to say that, this once again, this is a changing environment that the fish and the aquatic organisms have to deal with. It may not seem like a big deal unless you're in charge of a harbor where you have to dredge it so the boats can go out, something like that, maintaining the infrastructure along the lakefront, or if you're doing a wetland restoration along the lakefront and the water levels are going up and down, you have to plan for that, all right, because it's a very dynamic ecosystem and the fish respond to that. Now, another aspect that's changed the Calumet region over time is not so much water going up and down, but rather sediment moving around. And so this is a map of the Calumet area around 4,000 years ago, and this was all water, all right, where we were. So we're roughly, right about here. Okay, so this was underwater around 4,000 years ago. But what happened is up in Wisconsin and Illinois, there's these longshore currents that were basically eroding away the sediment and filling in the bottom of southern Lake Michigan. All right, and so over time, this starts to fill in with the sand and sediments. Occasionally, there's little discrepancies up here that cause blockages. You get these spits, and then you get these bays. These bays close off, and you end up with lakes, like Lake Calumet and Wolf Lake. All right, so that's where these things came from. This is where many of the dunes came from. All right, this is a driving force for much of the geology that we have right here when you look at the sand. And we can see some evidence of this if you look at these old photographs with all these lines. So this is 1937, and all of these lines are old dunes. These are old beaches. So one time Lake Michigan was here, there was a dune formed, and it slowly crept over in this direction. So these are your dune and swale type formations. which I suspect you've probably seen walking around in many of the nature preserves and parks around here. Most of them have been flattened, but you can still see some evidence, like near Powderhorn and some other of the nature preserves. This is sort of another map of that. So as these ecosystems change over time, we call that succession. And a lot of the earliest ecological work regarding succession was done by Cowles out at Indiana Dunes, looking at how plant communities change over time. Well, a colleague of his in the same area thought, this is neat, I'm going to do this with aquatic ecosystems in more or less the same area. His name was Shelford, and I think you were referring to Shelford earlier.
Yes, yeah.
And so what he did is he looked at streams, and so he did a study over here in Hickory Creek and some of the ravines up north. But he also studied some of the swales right here in Gary. And I'm going to zoom in on this square more or less. These are, these are 100-year-old diagrams, so bear with me. So here's Lake Michigan, and so here's all these, sand ridges with swales in between. And he thought, this is pretty neat, and I'm going to go in there. And he went fishing in each one of these to see what fish lived there. And this is what he caught right here. And if you will, you should kind of take this and rotate it this way. In other words, this is the one closest to Lake Michigan. This is the one furthest from Lake Michigan. And when he went further from Lake Michigan, he found far fewer fish than what he found near here. And the community changed as he moved inland. All right? So he sort of came up with this model like this, and I'll walk you through this. So initially we start right here, where we have basically Lake Michigan. But as the sand is coming down from Wisconsin and Illinois, it builds this ridge, and we get this lake behind the sand dune. And then over time, another sand dune forms right here, and we have another lake. All right, so this is the youngest lake, these are the oldest. And these older lakes are starting to fill in with plants. All right, and so another one forms, this one gets more. So that finally up here, here's our young, Lake Michigan's over here, our youngest lake, pretty open. But by the time you get here, you basically have a wetland that's choked with vegetation and filling in. Give this long enough, this will turn into a field and eventually a forest. All right, these communities are changing over time. And when you look at the fish, they reflect that. In that over here, we catch fish that we're more likely to find out in the open waters of Lake Michigan. They like to be able to swim around, they don't like to moor. Whereas you go over here, you get fish that are more used to living in really closed-in spaces with a lot of vegetation. These also tend to have less oxygen at certain times, so these fish are resistant to low oxygen levels. So we see these shifts in community as not only are the communities changing over time, but the fish are, again, we're down here. These are more or less the currents along the shore. So we're getting erosion up here, picking up the sediments, carrying it and depositing it down here, creating habitats, both terrestrial and aquatic down here. But the people up here don't really want to lose their land. All right, they bought that land, their houses are on that, their factories are on that, so they want to stop the erosion. And so over time, we've developed these groins, these long metal fences out there, and there's hundreds of them these days, to prevent sand from moving down there. So we've basically frozen this process. It's a system of stasis. And the impact of that is we are no longer creating these new habitats over here. We're not creating new dunes in the Calumet region, the Indiana dunes, or anything like that. While these habitats over here are still filling in or being plowed under by bulldozers or something like that. So we've sort of halted this ecological process. All right, we don't see this succession anymore, and we're because we're trying to kind of keep it in a stasis. We don't want to see this type of change, and that's been going on for decades now. Now, this is not the only way, and Shelford didn't really write about this. He wasn't talking about the erosion of the groin, but he was talking about the succession up there. Another way that we've halted a lot of physical processes over time is with rivers. And so this is actually Chicago River over here, does plains. This is Mud Lake, and this is sort of one of our classic examples that when there's a lot of rain, it fills this up, floods. You can paddle back and forth, at least a couple hundred years ago, and fish can move back and forth. And as was previously mentioned earlier, there are other connections down here in the Cal Sag that I would have shown, except I don't have as pretty a picture, but maybe I should ask them. Maybe there are some prettier pictures in the maps, okay? But there's a similar connection actually down here through Cal Sag into the Calumet region that some argue is actually larger and significant than this particular one right here, okay? But in order to facilitate that we didn't see these changes, we've taken a lot of these rivers, we've dug them out. This is a sanitary ship canal. Lined them with limestone basically or steel, and basically have stopped them moving as well. And so now we have like the Chicago River, the Sanitary Ship Canal, the Calumet Channel, large portions of the Calumet River and Grand Cal are now basically frozen in their banks. They're not, rivers should meander. They erode one bank, they create a beach someplace else. They're constantly destroying and creating all the time. This is another process that we have frozen. All right, and the fish now have to deal with the fact that their communities are no longer changing when for thousands of millions of years they were changing, and that's what they were used to doing. All right. Now I don't want to give the impression that just because we moved in here and there's a lot more people here that we've frozen all of these processes. We have actually impacted the environment. Oftentimes we use it for a number of uses. In this instance, it's for moving, whatever around the staging areas from barges to freighters and back and forth or whatever. Dumping grounds for garbage, creating factories, on and on. You know all about this. This isn't just a Calumet issue; it's all over the place. So we are still changing the environment. And one example that works out quite well for this, as Michael was pointing out a little bit earlier, was Wolf Lake. I'm going to assume everybody knows where Wolf Lake is. If you don't, let's see here. Which way is north? Okay, that way. Walk that way, and you'll figure out what Wolf Lake is. We're here. So Wolf Lake's a good example of this. These are just some pictures of some of the areas of Wolf Lake. But one of the reasons that this works out quite well is we actually know a fair bit about the history of Wolf Lake. And we don't always know that. I showed this diagram earlier. Once again, this is the sediment coming down, filling in the southern end of Lake Michigan. Around a couple thousand years ago, you see the spit. Lake Calumet's a bay, turns into a lake. Finally, we get Wolf Lake. You can go into some of the swales, date the vegetation that's been deposited there, and when you do that, you see that Wolf Lake is only around 1,000 years old, maybe a little over that. So it's not an incredibly old ecosystem, it's actually fairly young. Okay. Skipping forward, we have a great map of Wolf Lake from 1896. It's already been modified by this time with the various roads and railways and various other things. You can't see this here, but these are all numbers indicating depth. And at this time in 1896, it was no more than 4 feet deep, typically less. So it was pretty shallow. Here's some pictures in Shelford. Shelford wrote a book about ecological succession, and he had some pictures of Wolf Lake from then. And basically, it was just a little bit of open water in the middle of a wetland. All right, it was just a big wetland, open water. Go closer to the edges, you'll start to get shrubs. Go further away where it's drier, you'll get trees. You can see, you know what I'm saying. All right, so that's sort of the ecosystem that we were dealing with originally. That's the original case, and we have documentation of that, which is great. The first big change was the railroad that came through. Here's a better map of it, which is kind of bisected the lake right here. This map is from 1929. I don't know exactly when this was made, but sometime in the couple decades prior to that. The next big change, you can't see it too well here, but this is the interstate. So the Skyway, Interstate 90, cut through the middle of it. And it wasn't so much the highway cutting through the middle of it. It's that in order to create the highway, they needed a lot of fill to form the foundation of underneath the highway. To get that fill, Wolf Lake was one of the sources. So it was actually heavily dredged. This lake, at that point, and this was in the 1950s, was dredged from around 4 feet down to around 18, 20 feet. All right? So it was really basically scoured out. And they have all these levees here as these are access ways that they could have used to get in there. They kind of divided up into different pieces like that. So that really changed that. It also had a huge impact on Powderhorn Lake that wasn't really there beforehand, but was also a source of fill for the interstate. So that's a big change. Now, another aspect of this, we actually have some great information on the fish, and this is rare. And part of the reason we have all this information is the Field Museum, which is, the Field Museum, if you go behind the scenes, has over 1 million specimens of just fish. All right, they have 25 million artifacts and specimens of all kinds of other things behind the scenes. It goes on and on and on. But for just fish, they have over 1 million specimens, thousands of species from all over the continent. And one of those, or some of those, were from Wolf Lake. So in 1898, an individual named Seth Meek worked at the Field Museum in charge of the fish collection, and he grabbed a net, he hopped on a train, and he came down to Wolf Lake, and he caught a bunch of fish, and he put them in jars, and they're still in the jars there. We could go there today and see these exact fish that he caught. All right, so if there's ever any dispute about, did he actually catch this silverside there? Well, we can go there and say, oh yeah, look, here it is. All right, and he went back in 1899, 1900. Somebody else went there around 1910ish, on and on and on, all the way basically up till the present. I was there 2 months ago, a month ago, or something like that. So we're still getting fish from Wolf Lake. And so we can tie all of this together and sort of create a whole species list of all these types of things. And I know you can't read these, that's not important right now, but these are scientific names, species names. And then in this column is a particular series of years, in this case 1898 to 1937, marking which fish are there. And so at that time, which we take as our starting point, it's already been modified somewhat, so it's certainly not pristine, but it's still a large wetland. We know that. And these are the fish. They build the railroad through. We don't really have evidence that there was a big change with the railroad. But then there was not a lot of collecting in the 40s and the 50s. Maybe the wars got in the way for whatever reason, I don't know, but we don't have a lot of data from that point. But we do start to get a lot of data from the 60s after the interstate is created, and we see a lot of species have dropped out. And we have these. And then in the 70s and 80s, we see the addition of some more species, some more dropping out. There's always more and more home development. This is also a time when recreational fishing is starting to catch on more. People are starting to stock the lake with more and more fish to enhance the recreational fishing. We're also seeing a greater influx of invasive species. And then we see a bunch more that sort of pop up recently. A couple of key points that I want to make out here is the number of species does not change appreciably over time. Keep in mind that collecting methods have, so you got to be a little careful comparing it. Back here it's largely nets. Here we have sophisticated boats that can go out and do a bunch of different types of things. So we're better at it now than we were in the past. But in general, there's also at certain times where more people were out there working. Keep that in the back of your mind. But in general, the number of species doesn't change appreciably, but we do see a shift. And we sort of see three main classes. These are our relatively sensitive species that do not appreciate it when their habitats are destroyed or changed significantly. And when that happened, these dropped out almost immediately. All right, and we have not seen them since. Then we have sort of these generalists. These are okay if you come in and perturb the environment. They're okay with a little bit of pollution. They're not going to like a lot of pollution, but a little bit. They'll be okay. And so they've hung on for the past 100 years, since the 1800s. And then we see a bunch of new ones, and oftentimes these are a lot of invasive species that have moved in, basically like the brown goby here. So we see this shift in communities over time. And yeah, even though I talk about how the sensitive species have disappeared, some have actually remained. One of these is the banded killifish. One of the largest populations that we've had over the past decades has been in the Wolf Lake, Powder-Horn, Calumet region, Lake Michigan, basically in the state. Another sensitive species that has been there is the Iowa darter. This is an endangered species in Illinois. This one's threatened in Illinois. But once again, times are changing. We have the round goby. This is an invasive species. The round goby first appeared in the Great Lakes in 1990 in Lake St. Clair near Detroit. Its first record in the Chicago area was actually Calumet Harbor in 1993. They got there in the belly of freighters. So freighters, when they go back and forth over in the ocean, have something called ballast tanks. And what they do is they take on a load of goods. But in order to not be so tippy as they're going across the ocean, they will also take on water to balance out the load. Okay? And when they take in a load of water, they suck in everything else that's nearby. And some freighters, we believe, sucked in a bunch of round gobies over here and sailed across the Mediterranean, Atlantic Ocean, up to St. Lawrence, all the way over here, and dropped them off, we think, into Calumet Harbor. And that's how we have them now. And in Lake Michigan, they're along the Chicago lakefront. They are now one of the most common fish that we have these days. They're extremely common and have basically taken over. Zebra mussels, we believe, came the same way. Quagga mussels, if you've heard of quagga mussels, the same way. And so as these move in, these live along the bottom, darters live along the bottom. We've seen dramatic declines in some of the bottom species. Now, I don't want to give the impression there are still Iowa darters in Wolf Lake as of last year, as of this summer. So we know they're still there, but they're in reduced numbers, and a lot of other ones are in lower numbers as well. But the invasive species issue can be very, very complicated. It's not always as straightforward as you may think. Here again, another evidence of change. If we were to skip out into the Calumet Harbor, this is one of the first places this was closely documented, is we have this native fish called the mottled sculpin, which is a small brown fish about this big, eats insects along the bottom, aquatic insects, and lives among the rocks. Along comes the round goby, small brown fish, about this big, eats aquatic insects, hiding around rocks, living along the bottom. Unfortunately, the round goby is more aggressive than the mottled sculpin, and they have basically eliminated them. We are hard pressed to find a mottled sculpin in Lake Michigan these days. They're basically eliminated. So this is your traditional invasive species stories. The bad invasive species moves in, the good native species disappears. Well, over time, we started to see more of these things. Does anyone know what this is along the Chicago River? This, which is only this big, is the baby form of this, the smallmouth bass, which is native. What we didn't realize decades ago is that bass love to eat gobies. All right? And we see tens of thousands of these baby bass out in Lake Michigan these days. And not only do smallmouth bass like to eat gobies, largemouth bass eat gobies. And so we probably have more bass out in Lake Michigan right now than we ever have because there's so much food out there for them. A couple of years ago, someone was fishing in Monroe Harbor, which is right off of Buckingham Fountain, and caught this huge smallmouth bass, took a picture of it, weighed it, let it go, went to the local tackle shop fishing, was talking about his fish, how much it weighed. They told him, well, that was a state record. If you had brought it into a certified scale, you would have had the record. Aww. But he didn't realize it, and that fish was out there eating gobies probably, right in downtown Chicago. But speaking of, so that's some of the impacts of invasive species. This is how they sort of change the environment to some extent. At one time, there was a lot of talk about this. Now there's a lot of talk about this one. These are the Asian carp. This one happens to be a bighead carp. There are a lot of other invasive species in the area. So we have the round goby, alewife. If you've been here for decades, you remember alewives. I don't know, they're still out there. Weatherfish is another one that's in the area, kind of flying below the radar. A couple students are doing some great projects with those. Sea lampreys, still out there as well. These are fish that latch onto the sides of other fish, bore a hole, suck out their bodily fluids, basically, and that's how they make their meal. Goldfish are invasive. We actually catch goldfish fairly often. I don't know if people realize that. And they're not always gold if they're out there long enough and have an offspring carp. User chat smell. And this is another thing, is that technically, depending upon how you define invasive species or introduced species, but the salmons, rainbow trout, are actually not native to here, nor are Chinook salmon, coho salmon, brown trout. And this is another aspect of invasive species, is you sort of have your popular invasive species. People like these, and we actually put them out there intentionally because people want to catch them. And then you have your less popular ones, like the Asian carp, where we're spending millions of dollars to try to eradicate them. So they're both, neither are native, and yet we're spending millions to get rid of these. We spend millions to put these there. So here again, we're changing the environment as well. But despite the invasive species and all of this gets a lot of press. A lot of people like to talk about it. I would like to point out that we should really keep the focus on our native fish. All right, so these are all native fish. I won't talk to you about all of them. I could be here for days. I'll spare you that. But we really need to sort of keep the emphasis on the native fishes in this particular region. My particular specialty happens to be native fish. I'll switch gear for the next few slides until the end of the talk to a non-fish, and so this is the mud puppy. All right, that some of us were talking about earlier. This is a fully aquatic salamander. They can breathe with lungs, but they primarily breathe through these gills right here. So this is how they breathe. That's red blood going through there. They get to about this large. Very, very secretive. They come out only at night. We find most of them in the winter. They're very hard, and because of that, we know very, very little about them. We've always known that they were out in Lake Michigan. We've known that they were in Wolf Lake because we found them by accident from time to time. We knew it was a bit of a hot spot, but we didn't really know a lot about them because it is a lot of work to go out there and find them. And as it turns out, we now have a grad student, and I'm not going to talk about her project too much because she's given some other local project talks about this. I'm not going to steal her thunder. But so consider me a cheerleader more than anything right here. But here she is holding a mud puppy right there. Yes, this is Wolf Lake in the background. Here you go. Here's your oil containers as well. And we caught it just like right here. All right, and she's found now over 100 of them. So she's caught quite a few of them. Does a lot of stuff with them. These are some other students. She's from Southern Illinois University. There's one in the aquarium right here. And if this works, we'll see if this works. If it doesn't work, let's see. How do I get out? Oops, that's not what it does. Here's Wolf Lake, which we filmed from a drone a year ago with an auger, drilling a hole through the ice. She sets around 52 traps a night, so you have to drill a lot of holes. Puts a minnow trap at the bottom. We'll see a minnow trap in a little bit. Leaves it there overnight. So here's a whole string of traps in this particular section. See all the traps along here. All the gear that's associated with, here's some traps, but these are gear once you catch them. That's a minnow trap. Here's some bait in there. It's usually minnows or something like that. There's our mud puppy. Helpers standing in the cold. Oh, that's me right there to prove that I'm actually there. We're making a cameo.
That's not easy work.
It is not. No, that's flat. And it was really cold last year. So you weigh them, see how long they are. You do swabs to see if they're infected with any fungus, like that chytrid fungus, if you're familiar with that. We look to see what they eat. You can basically massage them and make them vomit up with their food there. See what's there. We put little transmitters in them, little microchips, so that we can tell if we can catch them again, similar to what you do with a pet cat or a dog. We're doing that with this here, so we can keep track of them. Here they are, getting the food, forcing it to spit out what it's been eating. We collect that, look at it under a microscope to figure out what they've been feeding on. Keep track and then release them.
How long do the microchips last if they don't get damaged in some way?
Yeah, they a long time. Yeah, it's not short term, but it could be a long time.
So what is the value of mud puppies? I mean, in the food chain or what?
Let me make sure I can actually find one. So I mean, they scavenge on things along the bottom. They'll eat small fish. They'll eat small dead fish. They'll eat crayfish, all that sort of thing. They're eating rusty crayfish, which is an invasive species of rusty crayfish. But yeah, they in turn are then eaten by others. Bass will certainly eat them if they find them and that sort of thing. So there's that aspect of the community. We believe they're relatively sensitive to toxicants because a lot of amphibians have very thin skin, so they absorb a lot of what they're out there being exposed to. So if there's a lot of harmful contaminants, we often assume that. Whether that's true or an accurate assumption, we can debate that, but that's often what we say. It's not such an issue in Wolf Lake or in Lake Michigan, but they're in Illinois rivers, and where they like to live. And another aspect is looking at the habitat where they that they like to live, where they're most common. And if we're involved with a habitat restoration project, we'll use and already are using what we learned here in order to recreate habitat in various places, like Northerly Island in downtown Chicago and possibly other places in Wolf Lake. They like to live in very thin cracks under rocks, not big ones, but smaller ones. In a river system, if there's a lot of erosion, a lot of sediment gets washed in there, those often get smothered out, and you will lose your mud puppies because they don't have their hiding spots like that too. So they're sort of an indicator. We use them as an indicator.
So a little bit of a barometer about the health of a body of water too.
Yeah, that's what we use that too as an indicator of what we see. And for some reason, and interestingly, they're not really a wetland species. So I bet that a couple hundred years ago, we probably would not have seen a lot of mud puppies in Wolf Lake, but because of these changes, because of the dredging and everything, we now have, it's certainly the best studied population of mud puppies in Illinois, and it's one of the most significant ones. And she's only looking at a small portion of the lake and has found all kinds of them. She doesn't have time to do the entire lake, so they're out there. But another fact, one of the reasons that we know they're out there is sometimes people will go ice fishing and catch them. They're most active in the winter and then just leave them on the ice. And so we used to find dead ones all the time because people thought they were ugly, so they tossed them out. Or they thought that they were eating the fish eggs and they didn't want the competition. Or there's all these myths and stories associated.
Do they have a unique physiology for being adaptable to the cold weather? I mean, is there something? I know some creatures have a lot of fat in their, skin and so forth like that, or in their bodies that enable them to deal with cold weather. But is there something like that with the mud puppy, or is it just that the water's warm enough down where they are?
So we don't know, actually. I don't know off the top of my head. We've been looking. We aren't studying that per se because that's a whole other aspect of this that would take some time to figure out. But yeah, there has to be, because they're most active in the winter, which is not what you see with the fish. Fish are most active. Fish are activities basically based on temperature. As it warms up, they become more active. As it becomes cold, they become less active. More or less, I'm generalizing. Amphibians in general do the same thing. If they're not hibernating or whatever, or like certain frogs that freeze completely. I mean, they're far less active. Reptiles, the same type of thing. These are the exact opposite. We don't know exactly why. And we can't find them in the summer. We go out there in the summer, we can't find any of them. We go out there in the winter, we find 100. Same place, same methods. And we don't think they're walking around all that. Well, they can't. Wolf Lake's not that big, so they can't go that far. In Lake Michigan, we've always been debating as to whether they're going deep, because they have been seen on wrecks 100 feet down. But even then, I don't think they're moving back and forth. We think that they're probably just really, really inactive in the summer. I don't know.
What do you foresee happening with the Asian carp? The media talk about it a lot.
Yeah, there's been a lot of, to say there's a lot of hype would be, here, I got a couple more slides, and then I'll get to that. But I did, just to wrap up, this is an old slide of the Army Corps plan that they did on the Indiana side. They've largely implemented, and I'm just trying, just to put in a plug that there are future plans for Wolf Lake. A lot of people are doing restoration projects here and other places in the Calumet region, and a number of the wetlands and such. Some are moving forward, some are not. Oftentimes it has to do with funding. And so basically, kind of thinking about all the stuff that I talked about the past, how we got to where we are today, we should use that information to try to make plans like this or something like this for the future as to what we want to do. But there's a lot of opinions as to what we want to do with these areas in the future. Some people would like to see Wolf Lake as just a great fishing hole. Others want to restore it into a condition like it was a couple hundred years ago. Those are not necessarily conflicting completely, but they don't always mesh completely. So we have a variety of opinions and a variety of ways to sort of move forward.
On that shoreline restoration, I was hoping that would be favorable to the Iowa darter because at least you got some shallow water. But would that affect the Iowa darter at all with what they've done on them?
Yeah, it should favor it. I don't know if it has or not. What Iowa darter's kind of like is a very firm bottom, not super hard, but like a sand bottom, something like that. You'll find them over sand, and then a lot of vegetation. And there are places that you can certainly find that now in a Wolf Lake. Yeah. And I know 2 places in the past couple of years where people have found Iowa darters. So yeah, so they're certainly out there. I remember looking for them sort of. Our people were looking for them, a decade or so, and couldn't find them for whatever reason. We were worried they were gone, but now they seem to have made a comeback for whatever reason. And it may be that the round gobies really did hammer them really hard for a time. But what typically happens with invasive species, and this can tie in with your Asian carp, is typically they're at pretty low levels for whatever reason. Something happens and they skyrocket, but then they overexploit the resources and they kind of crash and they just sort of cycle down to a lower level. So with the round gobies, we're kind of figuring out where they're going. We're not quite there yet with the Asian carp as to where they're going. Yes?
Do those Phragmites affect the fish population?
If the vegetation is too thick, we don't find any fish in them. So if it's a really, really dense stand, typically we don't find it. We'd like something that's a bit more open. So yeah, it does impact it. This, if it's a really dense stand of Phragmites or cattail or whatever that you may or may not have there, that can be, no different than a wall, basically. But what's more ideal is if you have a lot of inlets and other things that the fish can go in and out of, hide from predators, find places to eat bugs, that sort of thing too. I'm not going to say it's bad, but if it's really dense, then it doesn't help.
Early last spring in the forest preserve, the Cook County, it seems like some of those lakes had a lot of die-off among species like the goldfish and weird carp. And I remember asking some of the naturalists there, they said that the cold weather had actually been hard on some of the invasive species. Have you found that to be true? These last 2 winters?
It depends on the invasive species. Some of them do prefer slightly warmer temperatures, and I have seen a comeback of some native minnows that we have not seen many of, but with the cold weather and with Lake Michigan never really warming up, we've seen a comeback with a lot of some of the minnows that we haven't seen quite so many of. Whether it's going to last, I don't know, because this is going to be a warmer winter, we think. Nobody thinks that in the future we're going to have winters like we did the last couple consistently. So it depends. Yeah, it depends. But it can. It kind of depends on where the invasive species
Yeah,
are
it seemed
coming
like it
from.
had a real effect on the goldfish. But
Yeah,
it was
that's
like
possible.
everywhere it was.
Yeah.
I just, for general cocktail talk, is there nothing that will eat an Asian carp?
No, well, there's all kinds of things that eat Asian carp, depending on their size. All right, so Asian carp, well, obviously they start off small, and when they're this size, like this, all kinds of things are eating them now. And that's one of the biggest areas of study right now is how are they fitting into the ecosystem and who's eating them and how much. Catfish are eating them, pike will eat them, bass will eat them, whatever. Once they get large, though, they outgrow most predators and not much is eating them once they get this big. One of the more interesting ones when they're about this size, not that we've seen, are pelicans. Pelicans actually can eat them as well. When they die, a lot of things will scavenge on them. Something like that. But that's the problem. When they get big, not much eats them except us. And so that's one of the control strategies is to go out there and catch a bunch of these things. And they're trying to develop food markets for the Asian carp. It's not been super successful. There's some. But that's one of the plans of trying to control their numbers and get something out of them. Yeah.
Future. With the climate change, in 30 years, what will the fish population be able to play?
So, I'd have to go back and look at it, a list of them, but the species that prefer cooler waters are going to be less common,
Right.
basically. And the species that are okay with warmer waters, we're going to see more of. For example, I talked earlier about the fish that had the 2 mouths or whatever in the jaws, the freshwater drum. That prefers warmer waters, and we're seeing more and more of them over time, basically. So I would anticipate that we're going to see more of those in the Calumet region. More drum.
And the vegetation will change.
The vegetation of the plants will change to some
Plants will
extent too.
change, so that affects what you have.
Another aspect, so water levels probably won't change because they sort of control it, so you're sort of cheating there. But a lot of the predictions with climate change is that we're going to get more intense rainfall in the spring and less rain in the summer. Whether it will play out that way or not is hard to tell. Temperature is easier to model than rain precipitation, basically. I look at, go home and look at the weather report. See how accurate they are with the rain versus the temperature. They usually can get the temperature more or less, the rain kind of dodgy.
Yeah.
But anyways, if there's more intense rain in the spring, you could end up with more flooding. Is that bad? Well, it's bad for your basement. Is flooding bad for fish? Not necessarily, because this is an opportunity for fish to get from place to place. If there's a lot of flooding, then the fish in Powderhorn Lake can probably swim to Wolf Lake and vice versa. So that's an opportunity for them to see new environments, depending upon how it's
And that probably happened more often 50 years ago than it does today.
Yeah.
The exchange of water.
Probably, yes. Yeah. So it is going to influence it. We're going to see fewer of certain types of fish.
But in 30 years, they'll probably be looking back at what you've been doing. And
It could be.
continuing, right?
And then we'll see.
And then-
Write a new paper.
Yes,
Yeah.
somebody else will be writing the paper. Yeah. Oh, have we run out of questions?
Well, how far do you think a mud puppy can walk on the shore?
You mean out of the water?
out of the water?
Yeah, not very.
Well, I saw a smash one on the bike path. Did you see that? It was on the.
I haven't been out cycling in the last couple of days.
Oh, well, this was I don't know, months ago. I think it was
okay.
some cool weather.
Yeah, so
They would have caught it and taken it out.
Maybe somebody caught it.
Because they don't survive outside of water.
not well at all, because their gills collapse, basically, so they can't really breathe. They have a lot of trouble moving. I'm not going to say it's impossible, but then getting back to the flooding, is there a possibility that there was any type of water or flooding over the bike path? How close were you to the
Not
water?
in that area.
Okay, then no, I don't think so. Maybe someone caught it and was bringing it home
Yeah.
because they thought it was weird and had never seen it, which is a big, happens a lot.
Don't most salamanders live in leaves and, in the forest?
Yeah, that's what
So
makes
how
the
are
mud
they
puppy
escaping?
unusual.
Oh.
Yeah, it's unusual that way. There's some other ones in the southeast, the United States, that are fully aquatic, but the vast majority, 95% plus, whatever. As you say, the best way is to roll over a log and find them under the log or in vernal pools or something like that. They'll live along the side of pools and stuff. So, yeah, that's more typical. That's the whole other aspect of it.
How long do they date back in Wolf Lake from? Or were they from 1897 when we started
The
logging
mud
Wolf
puppies?
Lake? Yeah.
We don't have many good records.
No?
No, not for Wolf Lake. It'd be interesting to look into that. Alicia should. Most of the records I know from Wolf Lake, I would have to go look at the Field Museum, see what they have there in their collections. I would talk to Alan Resitar, if you know him. Some of you probably know Alan. He's a
Yes.
mud puppy expert and something like that. And he was one of the ones that sort of pointed us in the Wolf Lake direction because he knew so much about it, and we knew they were there. So I would ask him, but his knowledge is only going to go back a certain number of decades as well, or something like that. We have records of them in Lake Michigan going back early 1900s, maybe even 1800s, so we know that. So, but no, we don't have good records.
It seems like such a different environment, Wolf Lake compared to Lake Michigan, and the same animal is in both
Yeah.
places. That seems odd.
Yeah, a lot of people didn't believe us they were there. Yeah, but they are. And a lot of them, for whatever reason. And and part of it is to figure out why are they so successful there, and can we replicate that in other areas?
I believe I heard that you can do a census of fish with testing DNA, looking for DNA markers in the water,
So that
in their species.
Yeah. So that's something called eDNA or environmental DNA. And the basic idea behind it is you go out and you get a certain container of water. Typically they use 2 liters. Maybe they use less now or a liter. So, like a Coke bottle of water or something. You put it through a really fine filter, glass filter. You then look on there to see if there's DNA on there. If it comes up, you try to match it to see what you think is there. And then if it comes up as a positive match for something, then the idea is that, well, that fish or whatever is then swimming around out there, and that was the source of their DNA, whether it's through their slime or scales or feces or something like that. Yeah. And so that's been used in a lot of the Asian carp studies as well. Yeah. But they're still trying to refine that technique because there could be ways that the DNA could move around without a particular fish. So they're trying to figure that out. Yeah, that's been a topic of discussion.
How long has that been around, that method?
Just a few years
Okay.
within this. They've used it, they use it on soils too, and so they've used it a bit longer in instances like that. Yeah. But in water, it's relatively recent.
If a mud puppy is a amphibian, correct?
Yep.
But how come it's always only in water? You ever find them in land? Because salamanders, when I've been hunting for them, they're living on the land under rocks and things.
Yeah, that's where most of them are. That's where they are. That's what makes the mud puppy unusual, is that it is not on land. It was just in the water. And there's a handful of species that do. But a lot of salamanders, even though we find them on land, many of them will lay their eggs in the water or go back and forth, typically in seasonal ponds. So they're this transitional one. It's just that a few species live completely in the water. And mud puppies is one of them. And because of that, we know less about them, because it's harder to go out and catch them when they're in the water. It's even harder to figure it out because they're only active in the winter, which is hard to do field work.
And have you ever thought they burrow over under sand in the summertime or something to hide? I mean,
Never found them there, no. Yeah.
Where did they go?
Yeah, so I will see them, and I've seen mud puppies in Lake Michigan in the summer. The times that I see them most often is when it's really, really warm. And sometimes we think that there may be a botulism outbreak. Botulism is a critter that lives in the sediment and under certain conditions can become common and enter the food chain. And when we think that conditions are right for botulism, I sometimes will see more dead mud puppies in the summer, but that's about the only time I ever see them in the summer. People do find them from time to time at other instances, but not as easily. So we know they're there in the summer, but they're just really hard to figure out what they're doing. And they don't seem to be doing much as far as we know because we can't track them.
From your perspective, is botulism something that is driving them into away from itself and toward a safer area, or is there some other connection?
They're dead when I see them. So probably what happened is they entered the food chain and they ate a bunch of whatever that had this in it, and they ended up getting sick and dying from that, and then they float onto the beach.
Misunderstood.
I'm walking along and I find them.
I thought you were talking about living ones.
No, dead ones.
So you've been talking to other, now, Lake Michigan, or Illinois isn't the only place where this study is being done, right? Other lakes in the...
The mud puppy?
Mud puppy
aspect
study.
of it, yeah. So they're doing a lot of work in the Detroit River on
Okay.
this part, and Minnesota's been doing a lot of other work. And Alicia has been talking with them, seeing what they learn, and do we have...
Okay, I was wondering if,
if
that discussion is going on. And of course, when the study is finished, you'll be incorporating them. I assume somebody at some point would be incorporating all the findings from all the different sites.
Well, if she wants a degree, she has to write up a master's
she has
thesis.
to?
Yes, so yes,
But
she will be. Yeah, so there'll be a written record of all of this and all the data.
yeah.
Yeah.
No, but I meant between Minnesota and Detroit.
Oh, synthesizing all of that. Well, they're publishing their own reports, and so that's a little bit disjointed. But over time, hopefully somebody
that
else.
would have to come
Yeah,
together.
yeah.
Okay. Okay, everybody hired?